Gently dip the wireframe in soap solution. Now take out gently out of the soap solution and the wire CD moves inside as shown. Then the wire CD experiences inward force automatically twice LdX. So this is a total change in the surface area of the film stored in form of energy. Where it is stored? It is stored in the film of that liquid. And this energy is nothing but called as a surface energy. This is liquid contained in a container, and this is the top layer of the liquid. This is a surface layer. This surface layer having large number of molecules. So these are the large number of molecules present at the surface. These molecules are affected by two forces. They are experiencing two forces. One is the upward adhesive forces. Upward adhesive forces. And second one, all molecules experiencing downward cohesive forces. So the surface molecules are experiencing two types of forces. One is the upward adhesive forces and downward cohesive forces. Why upward adhesive forces? Because the air molecules are present over there. Air particles are present above the liquid surface, and these air particles attracting liquid molecules. These surface molecules as well as attracted by inside liquid molecule. There are the large number of liquid molecules, and these liquid molecules, what they are doing? They are pulling the molecules of the surface. In liquids, these cohesive forces are much stronger compared to adhesive forces. They are very much stronger. Now at surface there are some molecules. Consider these molecules. I am shading with this orange color. So what happens? These molecules which I have shaded will be least stable. They are not very much stable, and they will be easily attracted in the downward direction. Therefore, these molecules easily go into the liquid due to the cohesive forces. So now remaining molecules, like this is the remaining molecules on the surface, they could not come inside, and they remain at the surface. Here is the one more molecule near the walls of the container. So these molecules which could not come into the liquid, they attract each other. They attract each other, and due to the attraction, they come closer to each other, and thus the liquid surface, the top surface of the liquid is like a rubber band, like a spring, like a elastic membrane which tries to come closer. So liquid surface film tries to become smaller in length. So the force per unit length is nothing but called surface tension, or we can use the small letter as well as F upon L equals to T. So it is called as a surface tension, force per unit length. is called surface tension. I already discussed F upon L equals to T in my earlier video. So in this video, I am not much discussing about F upon L equals to T. So force per unit length equals to surface tension. Now, there are the molecules which are already gone into the liquid. So there are so many molecules which are not present on the surface, they are present inside the liquid. So those molecules which are present in the liquid, you want to bring to the top. So they were inside, but you are interested to bring them to the top. So these molecules which are already present inside the liquid and you want to bring them to the top of the surface of the liquid, they will not come easily, because those molecules which are already present inside the liquid, they are attracted by other molecules which are present inside the liquid. So they are attracted from all directions. So it is not easy job to bring this molecule from inside of the liquid to the surface of the liquid. For that, we need to do work. Work has to be done to bring the molecules, to bring from deep of the liquid to the surface of the liquid. The work has to be done. What we do now, we shall bringing all molecules from inside to surface of the liquid like this. So every time, for every molecule, what you are doing? You are doing work. Work has to be done to bring the molecule from inside of the liquid to the surface of the liquid. And the work done is stored in form of potential energy. That means now molecules were inside, now we brought them to the surface. When you brought them to the surface, the potential energy of the surface is increasing. The work done is stored in the form of potential energy, and potential energy of the surface increases. Let E1 be the energy of surface molecules. The energy of all molecules present on the surface. So altogether, energy of the surface molecule equals to E1, and E2 energy of the molecule present inside the liquid, and E1 greater than E2. Energy of the surface molecule is more compared to the molecule present inside the liquid. Now there is this difference, E1 minus E2, that is equals to delta E, and that difference of energy is nothing but called surface energy. In today's video, we are going to obtain relation between surface energy and surface tension. To prove this, consider a C-shaped wire frame P dash PS dash. CD is movable arm, can move on this frame without friction. Now gently dip the wire frame in soap solution. Now take out gently and without shaking the wire frame out of the soap solution. A film is formed in wire frame and hold the frame in horizontal position. As soon as we take wire frame out of soap solution, then the wire CD experiences inward force automatically and the wire CD moves inside as shown. So wire frame is moving from position CD to the new position C dash D dash. CD is before, CD is the position before taking out from soap solution. But as soon as we take the wireframe out of the soap solution, the sliding wire CD moves from position CD to C dash D dash. So C dash D dash is the position of the wire CD after taking out from the soap solution. Soap solution. As soon as we take the wireframe from the soap solution, then the sliding wire CD moves from position CD to another position C dash D dash. It moves towards the film. Why it is moving? Because we already spoken that liquid surfaces have tendency to minimize surface area. So as to decrease the surface area, the film is moving from position CD to C dash D dash. And the film of the soap solution is formed both the side of sliding contact, front side as well as the back side. Both side it is formed. So we have to take twice the length of the CD. So surface tension T equals to F upon L. So we have to take the 2L here, twice L. So implies F equals to 2TL. Call it equation number 1. So we got expression for F, the force that is acting on the sliding wire CD so as to sliding wire moves from position CD to C dash D dash. For that a force F is responsible. So we got expression for force F equals to 2TL. Call it equation 1. Now imagine we pull the film by using external force F, and we also assume that the film remain unbroken. This F equals to 2TL is nothing but due to the film. So F equals to 2TL. And the force applied by us, external force, that is F dash. The distance between two position C dash, D dash and CD, let us call it as a dx. So distance moved by sliding contact CD due to external force equals to dx. So what is dx? Dx nothing but distance moved by sliding contact from C dash D dash to CD. One more important information. We are pulling the film towards outside through a distance dx. So how much force we need to apply? Equal and opposite force, that is twice TL. So F dash equals to twice TL. If we apply more than that, then what will happen? The film may rupture, the film may disturb. So to make the film not to disturb, we need to apply a force F dash equals to twice TL. Now, when we are pulling the film outside, we are doing work done. So let us call dW is the work done. Work done by external force. Work done by external force. So pulling the CD, pulling sliding contact through distance dx, we are pulling such that the film is not broken. This is important condition. If the film is broken, then story is over. There is no story. Story will remain as long as you are pulling the contact, sliding contact, and film remain unbroken. So before pulling, the sliding contact was at C dash D dash, and after pulling, it is at CD. So this much area we pulled it. This is the space. So this much area we pulled, and there is an increase in the surface area of the film. So let us call dA is the increase in area, increase in surface area of the film. So that is equals to, for one side, the area dA equals to L into dx, length into breadth. The length of CD is L, and area the area swept dA equals to L dx. For both sides, it is twice L dx. So this is the total change in the surface area of the film because we are pulling it. So there is an increase in surface area, that is equals to 2L dx equals to dA. As we are pulling, we are performing work. Work is done. Work done in pulling the film. Pulling from C dash D dash to CD. Let us call this work done equals to dW. And we know that work done is nothing but force multiplied by distance moved, that is equals to dx. And this force is nothing but F dash and dx. F dash nothing but 2TL dx. This is equals to T multiplied by 2L dx. So dW equals to T multiplied by 2L dx. Call it equation number 2. And this is equation number 2 and this is 3. 2L dx nothing but dA. Therefore, dW equals to, that is work done equals to T multiplied by dA. But dW is the work done. That work done is stored in form of potential energy. This is stored energy. Work done is stored in the form of energy. Stored in form of energy. Where it is stored? It is stored in the film of that liquid. And this energy is nothing but called as a surface energy. So work done is stored in the form of energy. And what is that energy? That energy nothing but called as a surface energy. Therefore, surface energy of film of liquid is equals to surface tension multiplied by increase in surface area. So this is the relationship between surface tension, surface energy, and change in the area of the film. So let us summarize. We have dW equals to T into dA. dW is nothing but work done in stretching the film, and this work done is stored in the form of potential energy. This work done is stored in form of energy in the area of the film dA, and this stored energy in the film of the liquid is nothing but called as a surface energy. So relation between surface energy and surface tension is given by surface energy equals to surface tension multiplied by change in the surface area. So after going through this video, I hope you got now relationship between surface energy, surface tension and change in the surface area of the film. I tried to simplify the topic. I tried to avoid unnecessary technical words. I tried to put in the very simple way so that you will get the topic into your mind. Once you understand the topic, then you can manage the technical words, you can manage the scientific words. So, and you write down your difficulties in comment box. I must know what are your difficulties, what are the topics you want to watch, you want to go through on this channel, you want to watch on this channel. So I hope at least you will write this time your difficulties and let me know your difficulties. Once I come to know your difficulties, I will try to solve your difficulties through the videos and through the channel. So meet you again with next topic, hoping that you will write some comments, your difficulties in comment box. If you like this video, please share with your friends so that more and more people will get benefited. Meet you again with next topic. Till then, wish you good luck. All the best.